What is the trend that you notice here going across the periodic table?
You can tell that the atomic radius is decreasing.
You can tell that the atomic radius is decreasing. Let's see how many people agree with that. The atomic radius is decreasing. Bhavna, you agree with that?
Yeah.
Emiri, you agree with that?
Yeah.
The atomic radius is decreasing. Who disagrees with that? No one disagrees with it. Decreasing, 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 decreasing.
But then why is it so there?
Well, why didn't you disagree then?
I didn't say anything.
But I did ask the question, didn't I? I said, how many people disagree?
I was still looking at it. I was taking everything in.
Oh, you were taking everything in. Okay,
Yeah.
Garima. Now, this is one important discrepancy that we have here. And it has to do really with how we end up getting the atomic radius. There's something that can happen with elements like nitrogen and oxygen and fluorine, but it cannot happen with neon. How do you actually get the value for the atomic radius? One way is to get the covalent radius. So the covalent radius would imply what? One fluorine connected to another fluorine by a covalent bond. Then you have a nucleus and you have a nucleus. Then you get this distance, and how would you get the radius? Divide by 2. So it's not going to be possible to calculate a covalent radius for neon, but we'll calculate something called the van der Waals radius. And calculating the van der Waals radius for these would be difficult. At this stage, what we would say is that this is determined when you have a single atom by itself, weakly bonded to other atoms around. That's how neon exists if you have neon gas. There are very weak interactions between one neon atom and another neon atom called the van der Waals interaction. Whereas when one fluorine atom interacts with another fluorine atom, you get F2. And you can get a covalent radius. So because all of these radii are calculated one way, and neon has, because of its unique electron configuration, has to get its atomic radius determined in a different way, then we have this little discrepancy here. From what we know about the periodic table, if I asked you to predict in period 3, where would a discrepancy lie in period 3? Here where you would then have fluorine and argon. So what we are going to say mainly about going across a period is that the atomic radius decreases. And how would we explain that decrease in atomic radius? So first I dealt with the discrepancy that exists here between fluorine and neon, chlorine and argon. Now we're going to explain the whole thing going across. The effective nuclear charge is equal to this minus this, and I have lithium worked out and I have nitrogen worked out. Anyone wants to explain how I get this value for lithium? What is Z and what is S?
Z is the atomic number, so it's the number of protons.
The radius of lithium, which is the distance from the nucleus to the outside, that's the radius, is based on these 3 positive protons attracting this one outside electron. And how much it attracts that electron determines how much the atom can spread out and have a particular radius. So the value we've given for lithium is 130. And the value that we've given for nitrogen is 71. For lithium, Z stands for what now? Protons. And S for what? The first shell. That first shell that is shielding the second shell. So in this case, there's only one shell that's shielding. Here, there's going to be more than one that's shielding. But one shell that's shielding all the way across, S is going to be the same value. Tell me if you see that. Because it's period 2, they all are going to have one energy level full and then the valence shell around. So always cross the entire of period 2, S, which is the number of inside electrons, which we call the shielding electrons. That would always be 2. And this is 3 for lithium. But look at nitrogen's calculation. 7 and 2. So it becomes 5. So Z with this subscript EFF, the effective nuclear charge, is based on the 7 protons, but we're going to subtract these 2, which are the inner electrons. So here the effective nuclear charge is going to be 3 minus 2, which equals 1. And here it's going to be 7 minus 2, which equals 5. What is it going to be for fluorine? 9 9 minus 2. So the effective nuclear charge is increasing all the way across. And is it even higher for neon? Yeah, it's higher for neon because it's going to be 10 minus 2, which would give you 8. But we have explained why this exists. This is a technical point based on how we measure this. Apart from that, all of these are measured in the same way. The value that we get for Z effective, or the effective nuclear charge, is directly related to this decrease in atomic radius. So this minus 2 that we are going to have for the inner shell is based on what we call shielding. Find these three, find their atomic radius, then using this example here, I want you to write out your answer to justify whatever trend you get in the atomic radius of these three.